this video, what I'm going to give you is an organizing framework that kind of draws a bit out of the total survey error framework and converts it to the administrative records framework. So essentially what the policy issue is what we want to understand is describe the quality of the information that's being provided. And this has been very central, I think, to a lot of policy. There's an excellent memo that was put out from OMB at the White House about describing the quality of information that is disseminated by federal agencies. I strongly urge you to go and take a look at that. But essentially what they're trying to do is to say, data is the beginning. What we're trying to do is to create information that has value. So how do we measure quality? How do we ensure that the data are being, that are being generated create information that is useful? And that's at the core of inference. So when we think about quality, there's a lot of great thinking that has been gone into this. And what's the framework that we might want to think about? Now, obviously, timeliness is really important. One of the things that was attractive about the Google Trends was that it was timely. If you had to wait 2 years for the CDC guidelines to come out, it would be useless in terms of directing hospitals and doctors about a flu epidemic. A week or 2 weeks, even that is a little late. And that's why the Google flu trends was quite attractive. In terms of unemployment, private companies like ADP, which is a payroll processing company, is coming out with earlier unemployment measures than the Bureau of Labor Statistics because people want to know what's going on in the local labor market. So timeliness is clearly an important measure. You also want a measure that is close to what you're interested in. You don't want to have something that is completely uncorrelated with the underlying latent variable of interest. We've already talked about coverage. In other words, are you sure that the group from which you're collecting the data is representative of the population of interest? Then you also want to be sure that if it's going to be actionable for evidence, that the level of geographic detail is the one that's needed. You'll see a lot written about the challenge with national statistics is that a lot of implementation, a lot of decisions that are being made are at the local and the regional level, and national statistics aren't necessarily particularly helpful for that. And then another thing is you want to have longitudinal consistency. You don't want just the right geographic level of detail, the right spatial detail, but you also want temporal consistency. So what that means is, you know, if you're going to get a number, you want to be sure that you can compare it not just to a neighboring county or a neighboring area, but you want to look at, has it been the same over a reasonable period of time, so I can think about trends. So different measures are going to have different and different ways of collecting data are going to have different levels of quality along each one of those dimensions. So one of the core questions that we have to face with inference is, how do we trade those off? And, you know, from the producer's point of view, what you're interested in is you want the data to be accurate, you want it to be credible, you want it to be comparable, you want it to be coherent. So those are the types of things that a statistical agency focuses in on because that's what they can control. From a user point of view, as we just said, it's got to be timely. People need to get access to the data in order to make sense of it. Want it to be complete, in other words, that it captures people of different race or ethnicity or different types of firms. It's got to be relevant, so it's got to be actionable. And really importantly, and kind of hard for us geeks to realize, is it's got to be interpretable. So a set of regression tables with coefficients is probably not particularly helpful to someone who needs to figure out what do I do with this data. So one of the wisest things that I ever learned when I was working with the Census Bureau was I would geek out on, wow, this is a really cool measure. The LEHD data can give you more information about hires and separations, really detailed age and race and sex categories, really detailed geography. And I'd stop there. And what I learned from very wise people at the Census Bureau was to say, so that you can do X with it. So that interpretability and relevance is as important as all the other features. And that's a very important thing to remember. So as you're working with your data, try and remember always to think about the so that question. So let's talk about, and this is, I know, a very dense slide. I think it's an excellent slide, so I'm going to walk through it in some detail. And the survey error framework is based on 40 years of work with surveys. So, we talked very briefly about what's the underlying construct. So if you think about unemployment, what are we trying to capture here? How are we measuring it? Is it an hour a week in the survey week? Is that a good measure? How are people responding? And then how is that response getting processed? Then you want to think on the representation. I'm going to get a population mean. How different is the sample going to represent the population? So that's the coverage issue. That's the Dewey-Truman issue. Then how am I going to run into trouble with people responding, like people hanging up the phone, not wanting to answer? If they're exactly the same as people who would have answered, it's not such a big deal. But if they're systematically different, you're going to get bias. So, and then the way in which the statistical agency adjusts for non-response can also add some error. And all of those things are going to add up to your survey statistics. So taking that survey error framework, I'm not going to go into it in too much detail because there's so much good that's been written about it. And now let's think about it from an administrative record approach. So if I'm dealing, for example, with patent data or with grant data or any of the different sources of data that, that have been generated from administrative surveys, or sorry, administrative records, what you want to think about is, okay, I might have a measure that is called employment or having a job. How close is that measure to the measure I'm interested in? How close is that at every step of the way to what is generated? So and I'll talk more about this in the live lecture, but it's worth just unpacking these pieces so you've seen it in advance. In the representation in terms of objects. So for example, when I'm talking about the wage records, the unemployment insurance wage records, the population is the covered employers. So that's employers covered by unemployment insurance unemployment insurance that to a large extent won't cover the federal employment. Might not cover some parts of construction and some parts of agriculture. So there can be a frame error. If I'm talking about patent data, there might be some activities or a lot of activities that are not captured. So if you're thinking about capturing measures of innovation, you should be thinking about what's captured and what's not captured. And then you want to think about what's missing and how that might differ. Then when you're combining data, so a lot of the richness from using administrative data is being able to combine data from multiple sources. Once you start combining data from multiple sources, you might end up with a mismatch in terms of what's covered, what's not covered in these different data sets. I'm going to give a very specific example in just a second. So here is the data structure. What you want to do is you want to think about the columns, which are the measures of the particular features that you're interested in. And then the rows are the entities that are of interest. So for example, with patent data, I'd be capturing individual patents. And what I'm interested in doing is collapsing them into inventors, let's say, or collapsing them into businesses. So how do I combine those in a sensible way? If I'm dealing with individuals with jobs, people can have multiple jobs in a particular period. So how do I capture that piece of information? On the measurement aspect, if I'm dealing with information from corrections, which has race and sex, the problem might be that the measures of race and sex are only going to be as good as the options that were provided. And if people want to have different measures of race and sex that are not being provided, that information won't be captured. And then you can also have actual cell error, which is when information gets captured by different units. So for example, a patent examiner might be, you'll have different patent examiners capturing information, and a patent examiner might classify routinely a particular type of patent into one category versus another patent examiner might categorize it in another category. Different firms might have different specific reporting errors that could lead to systematic bias in the results. And of course, when you start integrating data across data sets and you're merging, there can be merge errors, and we'll talk about that within the linkage videos. So understanding how data are generated can be super interesting. You should definitely take a look at the spurious correlations example, because you'll see all the crazy ways in which just putting data together without understanding how the data are generated will lead to very weird things happening. More seriously, I should say, you can see, for example, this example from the United Nations study of how to use administrative records from different sources. If you compare this information from education with this information from the population register, and you're trying to link these data sets, you want to think through about the ways in which the errors can creep in as a result of different administrative records procedures. So it's worth, before you start just diving into the data, stop and think a little bit about how the data were generated. And you can see just from that simple little comparison of these two register data sets, which are made up, obviously, could result in very different findings. So as before, I've got a set of questions for you. I'd like you to take a look at these and be ready to answer questions in class. Thanks.